Think about your morning today. Maybe a coffee machine brewed your cup automatically. Maybe a phone unlocked with your face and the bills might already be set to autopay. Your calendar schedules itself and the smart assistant reminded you of today's event. Automation has quietly woven itself into our lives. It's not just about robots in a factory anymore. It's in our pockets, our homes, our offices, and it's advancing fast. AI is now writing code, designing content, doing things we once thought only humans could. It feels magical, almost invisible. But here's the catch, it's only invisible as long as it works. The moment it breaks, it becomes messy. And today, I'm going to take you behind the scenes of automation. Good afternoon, everyone. My name is Gaurav Choudhary, and I've been working with BBD for the past few years as a platform engineer. And today, we'll be learning about the hidden costs behind automation. Because while automation can save us money, time, and effort, when done wrong, it can do more harm than good. We live in a world obsessed with speed, scale, and efficiency. We automate deployments, tests, responses, even decisions. And why not? It makes our lives so much easier. But here's the problem, automation doesn't understand whether it's doing something right or wrong. It just does it and fast. And that's where the danger lies. I encountered this in my very first year as a platform engineer. We used to store our application secrets in a set of files, rotating them manually and then syncing with the clusters. A slow, repetitive task, exactly the kind you would want to automate. So naturally, I was tasked with doing just that. I built a script that would push all our secrets to Amazon Cloud and then sync that with the clusters automatically. Clean, efficient, elegant, or so I thought. I first rolled it out on the staging environment. Everything worked flawlessly. And since staging and production shared the same secrets, I felt confident. After 2 full weeks without any issues encountered, I, I decided it was time to take it live. So on a Thursday morning, I deployed it to production. No issues whatsoever. Come Friday evening, I was at a small get together with my friends. It's Friday night, music's playing, drinks on our hands, life's good. Until my phone rings. The caller ID shows an unfamiliar number from South Africa. My stomach sinks. I pick it up and it's the operations team, just was what I was afraid of. Hey, it's the operations team, we believe, regarding you were working on those automation secrets and some service of baking because of that. In my head, I was already booting up my laptop. So within minutes, I logged in with the ops team side by side. We started combing through logs, trying to understand what went wrong. Here's what. Yes, staging and production shared the same secrets, but four seemingly insignificant secrets that didn't share the same pattern. My automation, blind to that exception, dutifully synced all those values into production. Uh, and just like that, the very elegant time saver became the very thing that brought those services down. That night, as we scrambled to restore the services, I realized problem wasn't in the code or the missed exception, but in my assumption that automation once working was done. By automating without accounting for edge cases, I had built an automation that could make mistakes far faster and with greater impact than any human could. It was a humble reminder that automation doesn't mean always making things faster. It means to make them smarter. And sometimes putting in a little extra effort at the beginning can save us from a lot of harm and sometimes even a lot of Friday night phone calls. So this talk is not about blaming automation. It is to understand what happens when we rely on it too much. We assume automation is intelligence, when it's really just obedience at scale. The worst failures in automation are the silent ones. When a script fails, you investigate, right? Uh, what might have gone wrong. But when everything seems to work, The pipeline shows green, you trust it. There's no urgency. And that's the trap. The pipeline shows green. And the pipeline shows, when the pipeline shows green, you uh, don't think about, okay, let's see if there's something wrong because you trust it. Now, the problem isn't in the code, it's in the assumptions that you have made. We often automate to reduce the friction, the need for approvals, manual checks, or reviews. But those frictions are actually the safety points. They are the places where someone can catch a mistake. If we remove those without adding it built context or validations, we're just trading effort for risk. Automation done poorly uh, makes you feel like you have made some progress, but really you have just removed your brakes. Now, automation isn't something new. It's been here for a long time. Let's look at some past few cases, how they have gone wrong. Knight Capital was one of the largest trading firms on Wall Street. In August of 2012, they decided to roll out a new automated trading software. They had a deployment script that would push the new software to all of the 8 trading servers. But their script had a small silent flaw. If this script couldn't find a server, or if the service was down, it would quietly skip it. And unfortunately for them, the server was one of the servers was down for maintenance. So now, since one of their servers didn't receive the update, when it came back up, it was running an old piece of code that should have been buried long ago. And now no one knows how that part happened, and no one noticed. The next day, when the markets opened, everything looked fine initially. But then the servers started making wrong trades. The engineers panicked and scrambled to fix it. When they couldn't, they decided to roll back. But the rollback included that same old code in one machine that didn't update. Now, after the rollback, instead of one machine making the incorrect trades, all the machines started doing that. So instead of calming things down, they had accelerated the problem. All of these have all of this happened in just a span of 45 minutes. And in those 45 minutes, the company lost a whopping $440 million, all just because of one missed update, one overtrusted script. So lesson here is that automation will do exactly what you tell it to, even if that means driving you straight into a wall. Without validation checks, without verification steps, you're just moving faster towards disaster. Let's look at another infamous case of GitLab. Many of us here use GitLab and have worked with it, right? Imagine all of your commits and merge requests disappearing overnight. That's what happened in the February of 2017. GitLab experienced a massive spam attack that filled their servers with junk data. When the engineers couldn't contain it, one of the engineers decided to remove the directory affected. In the heat of the moment, he ran the command in the wrong directory. So, whoosh, just like that, all the data was gone. No confirmation prompt, no safety nets. But it gets even worse. Uh, Confident that they could recover the data, they reached out to the backups, only to realize that the backup was already corrupted. So the very system that they were relying on had failed long before this incident even happened. They eventually had to roll back to a 6-hour old data backup, but all the data between that time was gone forever. Automation is only as good as the balances and fail safes you built into it. A wrong command can cause damage, yes, but the real disaster happens when a backup is untested and broken. The lesson here is brutally simple. A backup that isn't tested isn't a backup at all. It's a false promise. Now let's look at how automation done wrong can even take lives. In 2018, Lion Air flight uh, took off from Jakarta, Indonesia, with 189 people on board. Just 13 minutes into the flight, the plane plunged into the Java Sea. 5 months later, Ethiopian Airlines met the same fate, crashing just 6 minutes after takeoff. Both these incidents had one thing in common: Boeing 737 MAX. Boeing had introduced a new piece of software called MCAS, Maneuvering Characteristics Augmentation System. On paper, this meant to make flying safer, pulling the nose of the plane down if it thought the plane was climbing too high. But MCAS relied on a single sensor for its data. When the sensor fed false information, the system panicked. Pilots, unaware of the full context of the system because Boeing hadn't documented it clearly, fought desperately to pull the plane up. But they didn't realize that they were fighting automation itself. Boeing had automated a life critical system without putting manual override or adequate context for the pilots. They had prioritized automation to reduce costs and stay competitive. The result, a system that worked on paper, but in real life had no safety nets. And that is the cost of automation done wrong. When you automate without verification, without enough context, and without transparency, sometimes lives are at risk. In all these cases that we just saw, one thing was common: automation wasn't the enemy, but poor judgment and assumptions. Automation did exactly what it was told without questioning intent. We build pipelines to test syntax, pass builds, and deploy, but we don't always validate meaning. Was it meant to do that? Was that flag supposed to be true? No, are you sure moments. And this and all these scenarios, automation behaved correctly, but the systems that they were using didn't question those risky actions. So automation didn't fail, systems did. And when you add automation to faulty designs, they fail at scale. And this is going to get even worse with the advent of AI. Today, we are seeing a cultural shift in engineering. Developers use tools like ChatGPT and Copilot for code suggestions. They accept it without thinking too hard. They call it vibe coding. They don't understand the systems they are modifying. They just interact with the above layer. They don't question how this change will affect my system. The AI does not know that one config change can take down your app because it does not have the full context. That's the developer's responsibility. So when you take code suggestions from AI and trust vibes or validation, bad things can happen quietly. AI is this latest shiny tool in the automation arsenal. It writes code, deploys it, tests it, and sometimes even destroys it. Uh, but problem with AI is that it doesn't understand consequences. It follows logic, but does not have judgment. Let's look at an example, and that helps us understand this better. This is a very recent case. Tech entrepreneur Jason Lemkin decided to run a 12-day coding experiment with Ripple's AI agent, which is a coding assistant. There were simple instructions: code freely, explore ideas, but do not touch production. A clear code freeze was in place with strict instructions not to touch live files. But AI, being AI, didn't follow that order. It obliterated it. So AI, in an unapproved sweep, uh, wiped out a live production database, and the story only spiraled from there. Instead of admitting mistakes, what it did, it created fake user accounts and fake tests so that to make the system appear healthy. When questioned about it, it lied. It said it had panicked and caused a near total catastrophe. This wasn't a misunderstanding. This wasn't a bug, but AI operating without visibility, without transparency, without any human instinct to stop when something felt wrong. Replis CEO Amjad Masad issued a public apology saying this was unacceptable and should never have been possible. The company rushed to implement strict separation between development and production environments. uh, stricter rules for code trees, and a one-click rollback feature. But yet the question remains: why were these guardrails not already in place? Because in a rush to innovate, these safety checks often feel like obstacles. Validations are nice to have unless they are the only thing standing between stability and disasters. We have seen this pattern again and again. We wait for the fire to install the smoke alarm. But with AI at the wheel, stakes are much higher. A human making a mistake may skip a checklist or misread a command, but AI making a mistake works at machine speed, at machine scale, compounds error faster than we can even detect. So the more autonomy we give to AI, the more critical it becomes to embed proactive safety mechanisms, not as afterthoughts, but as first principles. Because more dangerous than AI without brakes is an AI that can lie about what it just did. See, AI isn't evil. It's like a junior developer. It will act fast, confidently, and even incorrectly if you not check. So we must treat AI not as magic, but as a system that needs rules, boundaries, and humans in the loop design. Because while automation works great with predictable and repeatable tasks, it does not. What it does not have is context, because context is still a human strength. If we remove the human entirely, we risk deploying misconfigurations and incomplete features, because pipeline sees green and does not know any better. And these failures often aren't technical, and AI without judgment cannot catch them. Let's shift gears. Not all automation are bad. In fact, some of them are breathtakingly brilliant. Imagine you're watching a SpaceX rocket launch. The timer hits zero, engines roar, and the rocket thrusts upwards. What most people don't see behind this spectacular moment is there are thousands of automated checks running in the background. Every system, every sensor, every valve, tested and retested again automatically. There are layers of fallback. If one system fails, others take over. Millions of simulations are running before each launch. Even the tiniest of readings is off, the rockets don't fly. They call it off. No hesitation. Because hesitation can cost you billions in space flight. And then there's the landing. All of you, all of you must have seen the 20-story boosters dropping down from space. A human pilot, impossible. No one can make thousands of micro adjustments while winds and gravity fight back. Only automation can. But SpaceX didn't get it right the first time. In 2015, the rockets toppled over and crashed. But that failure fed into the automated system. New data, new correction, new resilience. Fast forward to today. Falcon 9 rockets fly routinely. They are used again and again. Costs plummet and space travels becomes more accessible. Automation here did not just save money. It created a new standard for safety. It showed us that it's not, we don't have to remove humans from the loop. We just create feedback loops that learn more faster than humans could. Therefore, accelerating innovations manifold. Let's switch from something from rockets to something closer to home. Netflix. All of us use it every day. Imagine you're watching your favorite show and the server hosting your show dies. What will happen? You will not even notice. You know why? That's because of automation. Netflix engineers had this radical idea. What if instead of hoping that the servers wouldn't die, we assumed they would? So they developed something called Chaos Monkey. This piece of software has one job: kill servers in production. Yes, on purpose. Now, at first, that sounds insane, right? Why would someone sabotage their own system? But here's the brilliance of it. Every time Chaos Monkey killed the server, automation rerouted the traffic instantly, spun up new replacements, and made sure the streams were running. The users, they didn't even notice. This idea eventually became so successful that Netflix expanded on it. And thus, the Simian army was born. A set of tools that tested whole regions, added fake latency, and even simulated blackouts. They didn't train the systems to just work in chaos. They trained their systems to thrive in it. The result, Netflix became unstoppable. Hurricanes, data center outages, hardware failures, nothing could knock it down. So the lesson here is automation isn't just about efficiency. It's about creating systems that are testable, observable, and resilient. If done right, it does not just make them faster, it makes them unbreakable. So, what really makes automation great? Great designs. Designs that are resilient and testable, adding validations and checks wherever necessary. Testing before you actually need them because it test them like it will break because one day it will. So from what we saw all these cases, whether good or bad, they are at a very large scale, right? So let's look at some good practices of how we can improve our systems. First example, imagine new hire joins a team and they request for a developer access. So the company's portal, its automated process, uh, they are approved, and but because of some misconfiguration and some maybe a flawed form, they are granted full admin rights instead of just developer access. Now, initially that might seem it might not seem that wrong, right? But in the wrong hands, it could mean altering production data, changing settings that could ripple across systems, and exposing confidential information. A good practice here is to build a second set of eyes into the process. Automate the process, but the final sign off for a high privilege permission must be from a human. Straight and simple. Let's look at another example. We all take database backups, right? At least I hope we do. But database backups is only half the job. Those backups pile on, and nobody really tests if they can actually be restored. Similar to what we saw in the case of GitLab. So a solution here is treat those backups not as dusty insurance, but as live asset. Every once in a quarter, you can go back to those backups and restore them. Do a drill, automate this entire process, but just add a human verification step to confirm the integrity. Last example, uh, an intern is asked to debug something in production. And now, by mistake or because of because they are new and out of not enough knowledge, they enable the debug mode on production. You know, it's these days. So now those applications work similarly, right? So even if its debug mode is on, it will work just as the same. So no one will really notice. But now your logs are verbose. They can expose API keys, variables, environment variables, and even secrets. It's like you have opened your house door with a welcome sign, and you're hoping no one will walk in. You did notice, but until a bad actor does and then exploits it. A good practice here would be in your automation pipeline, flag those risky settings and the sensitive configs. If they are detected, pair that with a manual sign off. Automation makes all these processes convenient and easy, but convenience is an accelerator for mistakes if you don't add verification steps. The cost of adding a manual check or restore drills, design time safeguards are small compared to the cost of permissions breach, failed restore, or a full blown data leak. Automation should never remove human judgment. It should amplify it by adding layers of validation that can catch errors before they become incidents. The solution isn't to remove AI, but add those validation checks, uh, create fallbacks. If a commit touches authentication, payment, or any critical part of the system, trigger a manual review. All these guardrails won't slow you down. They'll make sure you move without crashing. Now, it's not just a binary decision. It depends on the visibility, the impact, and visibility. So automation, if you know what you're doing, you will move faster. But if you're not, you will just crash harder. So what we have learned thus far, let's test your instincts. For example, you are a manager at a food delivery app, and the sales partner, they need a sales report every morning. Now you fetch the data, write an email, send it to them every morning at 8 a.m. or any specific time. Now, should you automate this or should you not? Just a yes or no. Yes, absolutely. Why? Because it's a simple, repetitive task. If the script fails, no one dies. A human can resend it, right? So, this is automation at its safest form: repetitive, predictable, and reversible. Another scenario: you are on call with your app team. Now, the app crashes, but a restart recovers it. So the team asks you to automate this process that whenever the service crashes, you should automate, you should restart it. Now, should you automate this or should you not? So this is a maybe, because the restart is a quick recovery for the app, right? But what if that crash is because of a bad code or misconfiguration? So a good practice here is to automate it, but limit it to a couple of tries. If it exceeds that, delegate to a developer who can dig deep, because automation shouldn't hide the problem, it should solve it, right? Last example that we'll be looking at: the marketing team uh, creates these campaigns, but it needs a approval from the marketing manager. So and the approvals are slow, so the marketing team asks you to automate the process, where just as soon as they submit, it should go live. So should you automate this process, should you not? No. It's at first it sounds convenient: instant campaigns and happy marketing team, right? But without by removing that checkpoint of a human sign off, you've removed the only step where someone with context and accountability has is can catch a mistake. They are the ones who will know the brand tone, the legal limits, and they are the ones who are accountable in case anything goes wrong. So a good solution here would be to automate everything up to the publish stage, but keep that manual sign off, because that human check is not inefficiency, it's insurance. Now let's justify the tagline of this talk: a little more effort, a lot less harm. How do we do that? Firstly, in automation is not about removing the humans, it's about removing the repeatable and predictable tasks. And and we do that by smart automation. And the smart part is what people usually skip. Smart automation means understanding the context before automating, adding guardrails, fallbacks, and validation checks, testing like it will fail, because one day it will. And then there's the little extra effort part. That is the people usually skip because of more work. So it sounds something like taking more time to add confirmation prompts, doing those restore drills before you actually need them, doing a dry run before deploying to production. These extra steps make sure you uh, you are secured, like, because these small steps will save you from the catastrophic failures. Because this is not doesn't just the bad automation doesn't just break systems; it breaks build and trust, sometimes even lives. So if you take anything from this talk today, take this: there's only so much we can do, right? We cannot add validation to each and every step. We cannot add fallbacks to each and every process. If something can go wrong, it will go wrong. We cannot foresee the future. We are not Doctor Strange after all. So if a config can go wrong, it will, unless you build a system that stops it. Automation should always assume the worst and be designed to prevent it. So what's the takeaway here? Automation isn't bad. Far from it. It's the most powerful tool we have, but it is only as smart as the thought we put into it. Unchecked automation can scale mistakes, but checked automation or smart automation is one that scales impact and safety. So here's my challenge to you. Whenever you automate in your work, don't just ask if this can be automated. Ask, should I automate this? How can I design it better? How can I add validation checks here? What will happen if this breaks? Because each and every one of you will design or rely on automation, whether in tech, business, or your daily lives. And the cost of ignoring those hidden risks isn't just bugs or downtime. It can be trust, money, safety, and even lives. As engineers, our job isn't just to write code, it is to understand systems as well. If we don't understand what our system is doing and just do as the AI suggests, we're delegating for future failures. So design better, add validations all that you can, build systems that people can trust. Let's not just automate, let's automate responsibly because that little extra effort that you put in will save you from a lot of harm later. Thank you. Hello. Yeah. So question and answers, please.
So you told we should add a human intervention. We should add a little bit of human intervention and automation. So, what will be the point when you are designing the automation? Like, how much the percentage ratio someone should choose? How much it's the automation? Like 70% automation, 30% human intervention. So, how should someone choose in this kind of scenarios when trying to create the automation for anything?
Okay, so there's no set limit for anything, right? Let's say in case of backups, we saw that the the backups are running automatically. They are taken every day, but you only go to them or restore them once in a quarter. So that's like very less human effort, very less human intervention. But in case of some automation scripts that's running or something it's more critical, you might need to check in a week. So it depends on the example, right? So let's say in this case, why I insist on human intervention is that AI is not that advanced yet. There's a recent case where at a company, the AI robot they used in manufacturing, right? And they one of those robots, instead of putting some tools into the machine, they put it inside a human, and that led to the death of that human. Now, who is accountable for that? There were not enough tests done on that robot or the AI to work at a place that was too soon for them. So something like that. It depends on the particular example. It for it someone it might be for some instances it might be once a year. For some instances it might be once a week. So there's no set limits as such.
Okay, thank you. Makes sense.
Anyone else? Any questions? I don't think so. Thank you.